Welcome to problem 4.3, where we will be comparing distributions with each other to show which distribution has the heaviest tail. So what is the idea of heavy tails? Let's take a look at, for example, two stochastic variables, x and y. So let's say x has a distribution f, which has density little f. So let's assume x has density f and assume y has density g. So if we were to draw these two densities in a coordinate system, we could have an example where, for example, f looks something like this, and g looks something like this. So the question now is often which distribution is best suited to model certain types of claims. And here we distinguish between which distribution has the heavier tail, so heavy tail, because if we have a distribution that is relatively heavy-tailed, that means that its tail out here for greater positive values is thicker, and that means that there is a higher probability of what do you call it, of getting bigger claim sizes. So heavy tail, you can kind of understand it as a higher probability of encountering big claims. And everything is kind of in quotation mark here because I'm just trying to explain the intuition here. So what do I mean by heavy tail distributions? They model claims where you have a higher probability of encountering big claims. Well, think of it like this. We can't just use the same distribution to model, for example, car insurance compared to fire insurance, because often car insurance does not involve as big claims as fire insurance. So we might choose a distribution with a heavier tail to model something like fire insurance, whereas we might choose a distribution with a lighter tail to model something like car insurance. So we kind of have stuff like the big things like fire insurance or natural catastrophes and so on, earthquakes and so on. The damages from these kind of things we usually model with heavier tailed distributions, whereas damages from car insurance or the insurance you place on your laptop or your bike and that kind of thing is modeled with distributions that have relatively lighter tails. So the cool thing is that we're actually able to show for general families of distributions which family of distribution that has a lighter or heavier tail compared to other families of distributions. And that is what we will be showing in this exercise. So there will be some things that we kind of need to use. So as you noted, I kind of explained the idea of light versus heavy tail by looking at the outer tails of, so the right tails of the densities for two different distributions. So if I, for example, consider the distribution with density f and the distribution with density g as the example I have given up here, then we say x has a heavier tail than y if the density of x divided by the density of y tends to infinity as x tends to infinity. So we say that x has a heavier tail than y if, while we're going towards infinity over here, if the density for x kind of is thicker in the tail than g of x, than the density for y. So this is what we get from also from the exercise text, actually, if you read it. So the exercise text also provides us with a couple of other definitions. So we say that x has a lighter tail than y. If this ratio tends towards 0 as x tends towards infinity. And equivalently, they also tell us that, well, this corresponds to the fact that so x has heavier tail than y if the log value of the density of x minus the log value of the density of y tends towards infinity as x goes to infinity. And this is kind of the equivalent of what we have up here. And the equivalent in the second case where x has the lighter tail is then that x has a lighter tail than y if the logarithm of the density of x minus the logarithm of the density of y tends to 0 as x tends to infinity, because this is just equivalent to this thing up here as soon as we take log on both sides. So this is the definition of heavier, respectively lighter tails. And what we will do next is, in the next video, we will just list up all of the densities, and then we will start comparing which distribution has a heavier tail compared to other distributions.